appreciate it. All right, so let's get started. We only have 50 minutes. So just some additional background about myself. I've been in IT for over 25 years. I've been teaching for over 20 at universities and community colleges in the Northern Virginia area. I got my original cyber training in the United States Navy in cryptography 20, more than 25 years ago, probably. And I'm married to a woman from Guatemala, and I have 4 children, and I'm a member of a Seventh-day Adventist church here in Northern Virginia. Okay, Alex?
Hello, everyone. My name is Alex. Yes, I currently work at Best Buy at the Geek Squad side. I'm an advanced repair agent. I provide some consulting and troubleshooting regarding technology and other technology, laptops, PCs, phones, stuff like that. I'm studying cyber. I've also been in the Northern Virginia Community College where I majored in information technology. I plan to get my master's, but yeah, I still got more and more to learn. And personal, I just like to play guitar on the side.
Awesome. And by the way, I asked Alex to do this because he's one of our top students. So I knew he would do a good job helping me. All right, so what are you going to learn in this presentation? My hope is that essentially I'm going to teach you what forensic tracing is and how it can be used to determine the maliciousness of an email, because usually illegitimate emails are malicious in one way or the other. We'll talk very briefly about email phishing as an attack vector. We'll go over the client-server architecture for email, which I think a lot of people don't truly understand, so I thought I'd include that there. We'll go over into basic email header structure, which Alex will lead the discussion on that. And then in there, how to determine where an email originated, and also how to perform a manual email header analysis. Also, even though the focus in this presentation is how to do things manually, there are websites where essentially you can put email headers and they'll do a lot of the work for you. In fact, there are even paid tools for that, but we're doing it in a different way, and I'll explain why in the presentation. And then we'll talk about some of the challenges to email tracing as technology evolves, as we move to the cloud, etc. Okay, so what are you gonna get as part of this presentation? You're gonna be able to, even though the site that we have only will upload PowerPoint presentations versions, okay, I'm gonna give you, and I don't know, Vicky, what happened yet last session was the moderator collected everybody's email addresses and then gave them to me, and then in a separate email from my GW account, I sent everyone a copy of the PowerPoint in PPTX format because it couldn't be overloaded. Maybe you could do the same thing today. And also, I have 3 labs to share with you that I actually use in the classroom. And I'd like to give that to you in docx format so that you can take it and edit and delete things, use it however you want in your classroom. So not only are you going to learn stuff, you're going to get stuff to take with you that you could use in the classroom, okay? So this is going to be our agenda today. We'll do a quick introduction to what email tracing is, a quick review of phishing, go over email architecture. Even though we're looking at headers, you can't really analyze the headers unless you know how an email travels. And then Alex will talk about email headers themselves and some of the specifics, highlighting those parts of an email header that are important for our discussion. And then one of the things that will be posted, that Vicky's going to post, is a lab called Analyze Email Headers for Cyber. I'm just going to do that really quickly in the interest of time, but it's a lab that you can take with you, study, play with, whatever. You can email me questions about, but I just wanted to see the format of how I do it in the classroom. I'll talk about automated analysis tools like MX Toolbox and Microsoft Message Analyzer so that you can have some experience with those. And then I'll talk about the key takeaways for the presentation. Okay. All right. So really quickly, I don't know hey, Vicky, were you able to upload the solve email spoofing mystery? I had it in an email.
I'm working on it now.
Okay, good. If you wouldn't mind emailing, but I'm going to get started. I'm going to give people background on this. This is one of the labs that I distribute in at the college, and I have my students go over. And I'm not going to. Don't have time to go through the details of the lab, but you'll have it with you in docx format. When I email it to you, you can use it however you want. But I wanted to explain what the importance is of understanding how email works. So, as you know, I'm a cybersecurity professional, and my kids are tournament tennis players. And they were attending a special program in Boyd's, Maryland, which is by Germantown, a special club called Montgomery Tennisplex. And I walked in one day for their practice, and they're usually on the court, and I'm somewhere else, where the parents are. And the director of the center, her name was Vicky, came to me, Datlow, and she said, "Dave, my email's been hacked," okay? So, I'm pretty calm, I've heard worse. So I was like, all right, so what makes you think your email was hacked? Well, guess what? That led to this lab. And essentially what happened was someone, they rent their tennis center out to college teams. Okay. And they had a relationship with UDC, and UDC was actually going to have a competition in their club in Boyd's, Maryland, with a team from another city. And she got a nasty email, basically, that was sent from her email to the coach of the UDC coach, saying, "Don't let these people in. They're terrible. They're known for stealing, etc." So my customers, now she's my customer. Her response was, "My email's been hacked." Right. So those of you who know in cyber is like, when I see my email's been hacked, well, first thing that came to mind, well, maybe she got a remote access Trojan, and you're right, maybe somebody connected to her a computer and logged into her email and sent the email as her through her email account. But that's very, very unlikely, because it's so easy to spoof emails, and that's what this labs goes over. So essentially what someone did was send an email, and it was able to make it look like it came from Vicky. But guess what? It didn't come from Vicky. Okay. And we did an analysis on the email by looking at the content of the email, comparing a legitimate email from her as opposed to the email that was sent, to determine that actually somebody actually spoofed her. Okay. Not even a very sophisticated attack, because the email they sent was full of typos, but they spoofed her and made her think her email was hacked. But that is the common reaction that you'll get from non-technical people, right? Because they don't truly understand. So I think understanding how email is sent, how email works, is going to be is important to almost every cybersecurity professional. So when you get a chance, go and do that lab, solve email spoofing mystery. And by the way, all the labs that I give you, they're the keys. So some of them have questions, so I put the answers in the labs. Okay, so just so you know. All right, so let's talk about what email tracing is. And basically, when you're doing tracing, is you want to find the origin of an email, right? Because emails today can come from anywhere in the world, right? One more story before I get back to the presentation to demonstrate this concept. I had a client in DC, and this woman had gotten malware several times, and she was very leery about opening anything. And I understood that, because she had opened Trojanized documents, infected her computer to the point where they had to get rebuilt. And so she got an email once. She said it was from her brother-in-law. Now, I had trained her to contact me before you open anything that looks suspicious, right? Just contact me. And so she contacted me and said, "Dave, I just got an email from my brother-in-law in California, but it seems very, very unusual. I'm getting this email." So I had taught her how to look at an email header, right? So she was using Outlook, the Outlook client, and she actually knew how to go find the header and do a copy paste and send that to me. And when we did a copy paste, I went over it with her, and it turned out the email originated in India. Okay. So what was that? That's a clue. Don't open that email attachment. It was actually a phishing email. Okay. So in a way, I did email tracing in that instance, just by determining what the source was. And what did I do? I looked, and Alex is going to talk about this in a couple of minutes. I basically looked at the first received line in the email header, which indicated the first, for lack of a better term, MX server or mail server. It goes by many terms. The first server where that email entered the system, and that first server where the email entered the system was physically located in, I think it was Mombasa, India. Mombasa? No, that's Nigeria. That's a different one. But it was located in India. Okay. So typically if you're in the field, you're gonna do tracing, because you want to trace back phishing emails or any kind of malicious email. And the way it works in the field today is that suspicious emails will be flagged by whatever technology the company has in place, right? And typically it's given to an analyst for further analysis, okay? Maybe to get signatures or, but essentially it is flagged usually in an automated fashion. There has to be an analyst typically looking at the header, looking for, signatures or, whatever he or she is tasked in the organization to do with those email headers. So viewing email headers by cyber forensics people or forensics people is not unusual. Okay. Now, I say in that second bullet could also be used to determine delays in email. Okay. I have actually did that. I had a customer several years ago who got an email 5 minutes, literally 5 minutes later than someone she knew. And she paid me a billable hour just to tell her why it was 5 minutes delayed. Okay. And really, I was able to determine that whoever sent it was a very, very large government contractor. In fact, they had something like 5 or 6 MX servers in their organization that this email passed through, which just shows how big they are. And there was latency at one server. Okay. So she spent me a billable hour. I don't know, it's $125 an hour just for being able to say, yeah, this server I don't want to say the company, had one server that was experiencing some delays. Okay. So sometimes you are going to be tasked to do that. Okay. So really, your goal is when you're looking to trace emails, you're looking for an IP address or domain name. Okay. Most of the time it's going to be an IP address, and hopefully that will give you some kind of clues to where the physical location is of the source. Okay. Now, usually you can't determine if an email is legit just by looking at one header field. Okay. You really got to look at the email in context. And one of the other labs that I posted, Analyze Email Headers for Cyber, will demonstrate that fact. Okay. Something could look suspicious in one place, but not look suspicious in somewhere else. Okay. And another thing is, if you get someone who has an email that you may think be malicious, well, if you work for the organization, you may have to deal with this, but I had clients, I was a contractor, they're not allowed to forward you the email. Okay, you actually have to get a copy of the original header from the customers. You have to teach them how to find the header and copy paste, and then essentially, you analyze that, because when you forward an email, what you're getting is a new email header, right? You don't see the original anymore. And by the way, that is very email client specific. Okay. I hear there are some clients that don't do that. They include the original email header, but I've got news for you. I've never come across that client. Okay. So why do we have to have this skill, right? Usually when you think about email tracing, it's actually related to digital forensics. But guess what? I have lots of students who are currently working in the field now, or once they start working, they tell me what they're doing, and they're telling me they're analyzing emails, okay, as part of their job. Okay. So really you need to know this, because our students need to know that. Okay. So let's quickly review phishing. And I kept this brief because I know a lot of you know what phishing is, right? But essentially, it's when a threat actor sends malicious emails either to steal sensitive information or to install malware. Okay. One of the problems with phishing is it's gotten much, much more sophisticated over time, and it's harder to determine what is legit and what it's not just by looking at the face of an email. So I went through my emails, and I keep samples of really good examples usually. And I got this email here, which really typifies phishing, right? It's immediate. See, it's this immediate verification for something, and it's sent by PayPal. I have a PayPal account, right? And then it asked me to confirm my details. Okay. So if you really look at this email, you could tell that it's not legit. There's just some unusual things about it, right? But so if my parents got this email, I have no doubt they would click on this, okay? But because I'm a cybersecurity professional, I can go a little deeper. So what I did was I put my mouse over the confirm details box, and I looked at the referred link. There's the link, when you put your mouse over a link, it'll show on the bottom left. And if you see what the URL is, it's PayPal II12 temp SW test .ru app, right? So guess what? Sorry, Alex, I know this wasn't you sending this, right? But a phishing email was sent from Russia, okay? Did I click on the link? Needless to say, I did not do that, okay? Now, I also said that some phishing emails can be used to distribute malware. I got this rather plain email, okay? And it has to do with an invoice. And, I was like, all right, I know this is phishing, but let me just find out what's in it, okay? And so I got this rather plain email, and then I got the attachment, this invoice 651-32223, and I basically saved it to my desktop, okay, right? You are aware that you can save attachments to your desktop, right? For analysis. What you can't do or shouldn't do is you shouldn't open the attachment, right? So what I did is I downloaded the attachment to my desktop, and then I fed it up to VirusTotal, okay? I think several of you know what VirusTotal is, right? It's a Alphabet-owned company that you can upload files to, and it's one of its features. It'll actually scan those files and determine if it has malware. So check this out. So I uploaded that file, and guess what I got? Well, you see the word Trojan all over there? This was a Trojan, okay? So needless to say, I have here confirmed some phishing emails do try to install malware. Then I had this one. I had to do one more because Professor Vargas is known for getting tickets, okay? I get speeding tickets. I mean, not intentional, okay? Maybe I'm going 5 miles over limit, but I get parking tickets. I get tickets all the time. And I got this one email about I got a ticket, right? And I'm thinking, oh my God, I almost fell for this. It's like, I got another ticket. So this was really convincing me. And I got afraid. I was like, wow, I got a ticket I didn't even know about. But this was a nice little attack because this was perfect for me. It wasn't until I started looking at it a little deeper to say, oh, no, this is not legit, okay? But right off the bat, I was like, yeah, I mean, this looked convincing. Somebody gave me a ticket and I'm being billed for it. Well, you know what? In this one too, I download the attachment to my desktop, and then I put it up to VirusTotal, and you'll notice Trojan downloader, Trojan. So once again, emails can not only be, redirect you to another site to collect credentials, phishing emails, I'm sorry, but they can also be used to distribute malware, okay? Now, I thought this one was really funny. A lot of our organizations use these like companies like, companies that to test their users with phishing. And I got this in my Montgomery College email, a very suspicious email, and I was kind of intrigued, right? You know, I was like, okay, um, it was an interesting enough email that it would have been something that I may have opened, right? So I said, because I'm trained in this, I said, well, I'm not going to open this. Let me look at the email header first. And I thought it was really interesting that it was clearly said it was from fishme.com. Okay. So what they, to me, this demonstrated, if you know how to email a header, look at a header, even for those tests that you're going to get in your organization, they're not going to work on you. So I have this bottom says, obviously the service catches only the low hanging fruit. Okay. So being able to view headers really is it's a good skill to have if you want to stay out of trouble with your management. So if we want to look at email architecture in general, this is what it looks like at a very high level, right? You have an email sender on the left, okay? And typically what they do is they're going to send their emails via IMAP or HTTP, okay? I don't mention things like POP because you don't really see it anymore. But when I looked at my client base, and I'm semi-retired now, they were all using IMAP for their email. And I'll explain why that is. So really, IMAP is what would the protocol that would be used to either send get email to their email server or retrieve email to their local email server. And that local email server, which we call an MTA or message transfer agent, could have been on-prem, which means on premises, or it could be some kind of cloud-based Microsoft Exchange. Before I started my retirement, I had a lot of customers that essentially were getting rid of their on-prem Exchange servers. Why is that? Because I got to be honest, Exchange is a pain in the neck to support personally. It was a pain in the neck for me because that's the only time that I would get emails from or text messages from presidents of companies because of email problems on the weekend, okay, that you had to address. So typically you're seeing Microsoft Exchange. Now, if it's on-prem or cloud-based, doesn't matter, but more and more we're going to the cloud. That's how you would get it to your local, your serving email server, right? In other words, the MX server whoever serves, whoever your email client is configured to send email to, okay? Once it gets there, it has to travel to its destination via this protocol called SMTP, okay? Simple Mail Transfer Protocol. One thing I've learned in IT, if it has the word simple in it, it's probably not simple, okay? And it traverses two or more servers, SMTP servers, on its way to its destination. I have found that this has changed as we've moved to cloud. Before cloud, you would traverse at least 4 servers, but what I'm seeing now is you're moving to cloud services, you're seeing maybe 1 or 2 servers, that's it. And that makes tracing emails back a little more difficult being in the cloud. So once it reaches the MTA, I'm saying Exchange, it could be anything else, but Exchange has to be the dominant email platform. The recipient is also going to use either HTTP or IMAP to retrieve that email. Okay, so why IMAP, right? One of the things with IMAP is that it's really designed to accommodate or move to mobile devices. So some of you remember when you're using POP for email, when you use POP, that email would be taken off of the email server, okay? And it would, in my case, when I was using POP, it would come down to my Outlook email client, okay? Now, if I wanted to access my email via the web, okay, and this is before the days of Microsoft OWA, right? But essentially, I'd go to my email server, access it via the web, but I couldn't access old emails that had already been downloaded to my client computer, okay? In that case, back then, I had to have remote control to my client computer so I could access just my Outlook email, okay? So POP would download emails and keep them on the client. Well, now people are accessing their emails, what? From their computer, their laptop, their tablet, their mobile phone. And so what IMAP gives you, it gives all those applications a common view of email. So what does that mean? That if I'm accessing email on my phone and I delete that email on my phone, well, guess what? It's going to be deleted when, or not present when I view my email via tablet or any other hardware device that I use to access email. Okay, so that's why we're moving to IMAP, because of the move to mobile devices. All right, so Alex, Alex is going to take over here, and I'm just going to tell me when to change the email, the slide. I mean, go ahead. Mm-hmm.
Yep, perfect. Thank you, Professor Vargas. So moving to the email headers, it's a little bit more technical part. Just a general view of the email header is, so like when you just receive an email, so it consists of 3 vital components. So first of them being the envelope, second header, and then the body message. So the envelope is something that an email has, but the user doesn't see it because it's the part of the internal process. by which the email is routed. The body is the part that we see, that's the actual content of the message contained in the email, and the header is the third component of an email. It's perhaps a little bit more difficult to explain, and through it's arguably the most interesting part of the email. So in the email, the body, the text that we see, is always preceded by header lines that identify a particular routing information of the message. So it includes the sender, recipient, date, and subject. Some headers are mandatory, such as from, to, receive, date headers. Others are optional, such as subject and CCC. So other headers include the sending timestamps and the receiving timestamps of all mail transfer agents that have received and sent the message. So in other words, anytime a message is transferred from one user to another, so when an email is sent or forwarded, the message is date and time stamped by a mail transfer agent, which stands for MTA. So it's a computer program or software agent that facilitates the transfer of email messages from one computer to another.
And by the way, in that slide, that's why I put the red arrows, because for the purposes of this presentation, really, we do focus on that received line, which represents the MTAs that Alex is talking about.
And next slide, please.
Mm-hmm.
So for the next, an important note is that the received lines that were marked on the previous slide, they're actually read from bottom to top, which is counterintuitive, one might think. So the first top received line is one's own mail server. Actually, if we could go back to the last slide, I think that would be, yep, that would be a good example. So again, so the received lines are read from bottom to top. So the first top received line is one's own mail server. The last bottom received line is the MXMTA server the email originated from. So while each mail system has its own style of the received line, it typically identifies the machine that received the mail and the machine from which the mail was received. So while the email header field can be forged, the received lines are created by email services that can usually be trusted. Next slide, please. And then the next slide, please. All right, so this is just a slide. This is an example of these are the main email clients that most of us use today. Office 365, Gmail, and Yahoo. That's the way you access the email header details. For these three, it's pretty similar. One says view message details, other says show original. The third says view raw message, essentially same thing. For the Outlook we all love and hate since it does give a lot of troubleshooting and errors to us occasionally. For that one, there is a specific path that is presented. So another important thing to note, when we cyber specialists, I don't know, IT department, when we get forwarded a phishing email, or sometimes what we ask for is actually to access that header from your client and copy paste it into the separate documents such as Notepad, text editor, because every time you forward a phishing email, it can lose that header information that we use to analyze to determine if it's a phishing or scam email.
I want to add something about Outlook. Alex, I know you troubleshoot that a lot, but if your customer goes, even if they go to cloud or they have on-prem server, on-prem, they're still going to use the full-featured Outlook. You know, they're not going to be using the web-based Outlook. You know, so in other words, they're not going to be using a web browser to access email. They're still using Outlook itself, EXE, because of all the other features that come with it. So going to the cloud doesn't mean regular Outlook is going away.
Cool. And then, so this is just a list of items, panes within the header. These are most of these are common sense from subject. What I think the most important is, that will be on the next slide. If you could switch to that one, that's the received pane that we mentioned earlier, and that was the one that was highlighted with the arrows. So besides the most common identification from, to, date, and subject, email headers, so they provide the information on the route the email takes as it's transferred from one computer to another. So what I mentioned earlier with the mail transfer agents, they facilitate email transfers. So when email is sent from one computer to another, it travels from through an MTA. So each time a mail is sent or forwarded, it's stamped with a date and time. So why the received headers are important, because if it travels through multiple recipients, all of them will be included in that received pane. So it's pretty much the same way the post office would route a letter. Every time the letter passes through post office on its route, it will be forwarded, so on, and it will receive a stamp. So in this case, the stamp is the email header. So the received lines, they provide information on where the message originated and what stops it made. So what computer servers before it reached the final destination. As for the example shows, the received lines provide the email and IP addresses for each sender and the recipient. So they also provide the date and the time of each transfer. The lines also indicate if an email address was part of an email list. So it is all the information that is valued by us computer programmers and IT department associates when we're making efforts to track and stop spam email messages. Next slide, please. So this is a little bit addition to the received field pane. So because it has received from and received by, so you would just interpret it as in a regular English sentence. So and then the next slide, please.
Okay.
Unless you want to add something. Okay.
No.
Okay. And then so the email had the ESMTP ID is so that it stands for Enhanced Extended Simple Mail Protocol. So it's generates a unique non-repeatable number that is added to every transmitted mail. So that adds to the security and you can interpret this to make sure the email is legit. Also, previously on the email header, there's a message ID. So message ID is something that easily can be forged, while the ESMTP ID is a unique, non-repeatable number that is assigned to every transmitted email.
So let me give you an example of that too. So say I send Alex a threatening email. I would never do that to you, Alex, but say, and for my corporate email address. And Alex sends that email to law enforcement. And, I say, I never sent Alex that email, whatever. Well, guess what? Using that SMTP number in the email that Alex got, law enforcement could actually go to the email administrator at my organization, and we could look up that ESMTP ID and confirm that the email actually came from that organization, from our email server, and from actually me. So it's something that would be commonly used in digital forensics when you're involved in email-related investigations. So it's a pretty good thing. Now, if you spoof that number, you can spoof that, and that means that well, let's say it's hard to spoof, right? I mean, because it's put on by a MX server. So because it's put on by an MX server that the bad guy typically doesn't control, it can always be traced back to the original, if that makes any sense. So I just want to say, okay, cool.
All right, this one is even more security that provides now for the emails. So DKIM signature and the domain key signature. So DKIM essentially stands for domain key identify mail. So that ensures that the contents of one's email remain trusted and have not been tampered with or compromised. So domain key identified mail is essentially an authentication method that's designed to detect forged sender address in emails, or when an email spoofing occurs. That is the technique that's used for phishing and email spam. I don't know. So the domain key signatures, it does involve the digital signature that does add to more security. I don't know if you want to elaborate on that a little bit.
No,
okay.
Not important for this discussion, given the time constraint. Cool. Yeah, thank you.
Okay. Message ID. So on the next slide, please. If you could go to the next slide, please. So message ID, again, that's what I was mentioning earlier compared to the ECMTP ID number. Message ID is much more easier to be forged and spoofed compared to something that is being checked by the MX server. My version, content type, these are just, these are not too relevant. And then if you could go to the next slide, please. So the X spam status, so that's essentially your email client based, I don't know if somebody flags that email for spam, and then the email client checks that sender, that email. So that spam essentially will be represented based on the work of the client if there's enough reports of that specific sender email for spam. So it will assign a specific value that you can look for in the email header. And then on the next slide, please. And then the X originating IP. So that's the easiest way for finding the original sender. That one is pretty straightforward. But I think, can that one be spoofed? I'm not sure.
Well, this is the problem with this one here. Typically, the X originating IP is going to be a private IP address. Okay, so no understanding. Say my email client, is 192.168.168.168. That's not really going to be useful for it's a private IP. So because of natting, so really you've got to go back and really look at the first MX server. So this may be important, maybe, but typically, and you want to look for it. That's one of the goals, to see if you can get an IP address that's actually a public IP. But I've noticed in looking at headers that a lot of time it's a private IP, and I just can't do much with it. Now, if it's a public IP, then you can do more with it, right? You can determine, it physically, kind of like the example with my customer where, she said the brother-in-law was in California, but then you can determine this IP address is located in Mombasa or somewhere else. That's a quick way of determining that it's not going to be legit. Okay. All right, cool. Okay. So thank you, Alex. I appreciate that. So in the manual header, I'm not sure. Vicky, were you able to post the analyze email headers for cyber? I'm not sure if people were able to get that.
I did.
You did? Okay. I'm not sure how many people were able to download that or such, but if you could download that and open that, I'm going to go right to, as I said, it's a big lab. There's, and once again, the intention of these labs, these are the labs that I use in the classroom with my students. So I'm sharing with you to hopefully that if you can find a use for them in your classrooms, you can do that. And you're getting a PDF, but once again, when I get an email from Vicky with all your emails, I'll send it to you in docx format so that you can manipulate it. But I'm going right to scenario number 6, which essentially, and by the way, these emails were all used with permission of the people who received and got the email. Just want to let you know. So I have a couple of examples here that are actually from GWU, okay? And in one of them, and what I do in the labs is I include legit emails with non-legit emails, right? So that students have exposure. Because I've noticed that when I share things with students, they automatically think it's wrong or, it's a compromise, whatever. So I tend to throw in things that are legit. So they don't think that everything a professor is giving them is obviously it's a compromise, or it's obviously, a phishing email. It's obviously malware. So it forces them to think a little bit. But in the first email header, and by the way, one thing I did in this lab here to confirm findings is typically I have them look at the email headers themselves in every line, okay? And I teach them not only to look at the email header fields, right? But to look at the content of the email. Is what's being said, does it make sense? Is the person who sent the email, is their email legit, right? If I'm getting an email from someone accounting at GW, well, I should see a GW email address, if that, you know what I mean? The unfortunate part is that, you only do that when you're suspicious. One of the reasons that, HR departments and payroll or what accounts payable departments are frequently phished is because they're usually in the position to click everything they open, right? They want to pay that invoice, right? Now they've gotten better over time, but those are two departments in our organization that are kind of trained to open everything. They got to view everything to see, if it's a job, email could have been a Trojanized PDF. Now they've been developing on solutions like this, all right? Now they don't open this stuff locally as much anymore because of the malware threat. But just note, but you've got to look at the whole email in context. And in that first email, if you look at it, it's a pretty big email header, okay? I should demonstrate that email headers can be long, but I want you to note that that email was actually legitimate. And the things that you got the key, but it's a legitimate because it legitimated, you actually see the source IP and it was a legitimate source IP. And also sometimes like the sender's email address is not accurate, right? And in this case here, the sender's email was accurate. So exactly accurate. So I determined that that was a legit address. Now in the lab, you'll see that I actually submitted the header to something called MX Toolbox. Because I said, when I started in this field, we just analyzed the header. And what I would do is I would copy paste the header, put it in Notepad, and I would delete everything but the received line, okay? And that's where my analysis was. Now, we'll see at the end of the presentation, these websites like Microsoft's Message Analyzer, MX Toolbox, Google has one also, that'll actually do this analysis plus more. For example, they'll analyze if the email originated from an email server that's on a blacklist, it'll tell you that. But let me tell you what's a problem with that. Whenever I put my email headers in these sites, my email server is blacklisted. Okay, so somewhere in the world, my serving email server has been blacklisted. Now, is it used to propagate spam? I don't think it is. It's a corporate email server. But just let you know, when you look at these results, you kind of, you can't just go by, exactly what they say, because, may be accurate, may not be accurate. In scenario number 7 was a little different, okay? It was also came from this, went to someone called the same person, it went to the same person and came from a different person. But one thing that's different from the first one, and the first one kind of go together, went to the same person, and that all good came from someone named Erkan, right? Well, Erkan had a different email address in this one. Also, if you look at the originating MX server, or what you call, mail transfer agent, it was actually not from Visa. They were trying to spoof Visa. Okay, so you look at my explanation there. Also, there were email addresses that are on the blacklist here, and the email address was incorrect. So, when you have time, take a look at those first emails and see my logic on why one's not legit and why one is legit. It's just, sometimes it's just minor errors, but you've really got to teach your users, essentially, if it doesn't look right, it's probably not going to be right, okay? And then I had, on page 14 of the lab, I have another scenario, which turned out to be not legit, okay? And for several reasons. This is why I keep saying Mombasa. This email actually originated in Mombasa, okay? And this actually was in a cloud, one of the MX servers was from a cloud environment. So there are tools like MX Toolbox, which we saw here. Now, I don't have them use MX Toolbox in these labs. I prefer that they do it hands-on. But a lot of times what I'll do is I'll throw a header up in MX Toolbox when I'm teaching this to save myself some time, to get some information that'd be harder to get otherwise. So this analyze email headers, like I said, use that. If you want any, another 1 or 2 email headers for your classroom, let me know. My parents get interesting stuff all the time that I have to analyze, and I get stuff. So if this is not sufficient, just email me. Maybe I can send you one really good one. I have one really other good one. So you just have to email, okay? Okay, so this is the most automated analysis. This is what I was talking about. Essentially, cyber professionals can use sites like MX Toolbox. And by the way, you see on the right-hand side, and this is only partial. I wasn't able to grab everything of the analyzed header on the bottom right. But essentially, it'll analyze each MX server. It'll determine its trustworthiness. It'll look, things like, DKIM, like Alex was talking about, determines whether it's good or not. And you have to make a decision on that. This is the interface for Microsoft's Message Analyzer. A lot of cyber pros like this one, okay? So if you're gonna go on and try these or do it with your students, I would try this one first, Microsoft Message Analyzer. This seems to be the one that people are going to. Very similar to MX Toolbox, but with some additional features. And then Google has one also, which I don't think is so great, but I gotta put out there because it's Google. So you can actually, what I've done in the past is I've actually put the same header in all 3 and see, essentially see what I got back. So what are the key takeaways of this presentation is that when tracing an email to its origin, you're really interested in determining, the email's domain or IP address, if you can do that, right? Because that tells you what the physical location is of the origin of the email. And like the example for my client, if the person's in California and the email originates in India, well, that's probably not legit, okay? And really you're looking for this thing called the X originating IP field, right? And the thing is, it may not have one, okay? So it may not have one. And if it has one, it may be a private IP, which may not be useful, okay? You have to remember that you have to work with the original email, right? Since forwarded emails have a completely different header. So if I've got an email of interest and I want Alex's help, I'm gonna have to copy paste that header. I'm not gonna say, Alex, check this email header out and forward it. It's just not gonna happen. But like I've said before, there are apparently some email clients, I've not come across them, but I've read about them. It's like Bigfoot. You heard about them, but you've never seen them, that apparently do include the original header, and I have not, okay? So every line in the email header can be forced. Please remember that. And really, the only one you can trust the most, really, and it's not really even useful, is just the line that reflects your own SMTP server, your own email server, and that's it. Okay. So as I said before, you can't determine if an email is legit just by examining one header field. You really got to look at a lot of things in context, and the Analyze Email Headers for CyberLab is going to demonstrate that with my first two scenarios. Okay. And one thing is I've noticed is that threat actors, just like organizations, have moved to the cloud. So when you're reading those, and by the way, they can create a, I don't know, a temporary account in DigitalOcean, do some bad stuff, and then move on to somewhere else, right? Or create a different account or a different name. So it makes tracing a little more difficult if you're just doing it for like malware, etc. Now, I'm not sure, and actually for forensics, it could be a little more difficult too, right? Because, if you have a search warrant for for the information in a certain email address, now you've got to work with the cloud provider to get all this information. And if it's a wily threat actor, you're probably not going to get essentially to, where you want to get to. This is why only the dumb criminals get caught, right? That's why if you look at this FBI Cyber Most Wanted, it's actually quite a large list. Now, I'm sure the fact that they're in Eastern Europe helps them, right, with no extradition treaty. But really, when you look at cybercrime, you really are catching kind of the low-hanging fruit, especially when it comes to tracing. And one thing to remember is that paid tools always do a better job and faster job. Okay, this is an example of what we call a utility used in email forensics called Mail Examiner. And I just thought this was a cool little graphic. So, instead of having to put your IP address in a geo IP locator, they will automatically tell you where the MX servers are reside. So it's very easily can tell that something is originating in Africa when it says it's coming from Venezuela, etc. Okay, cool. All right. I think we made it kind of on time, right?